What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to finally finish up our wireless section. This wireless section, just kind of going over the wireless fundamentals. And we're going to end it going over something that can be very, very in-depth, but we're just going to gloss over the surface, just a high-level overview. And that is the 802.11 frames. And this is going to be going over the association process, what the 802.11 frame format is, and essentially how a Wi-Fi enabled endpoint actually connects to that access point. What's going on the wire, and how does it actively send data? So we're going to jump right into it. And the first thing we got to go over is some technologies, or I guess not a technology, but more just a framework called CSMA/CD, Carrier Sense Multiple Access Collision Detection, then CSMA/CA, Collision Carrier Sense Multiple Access Collision Avoidance. So what are these two definitions, or why are we bringing this up? So if you're following these videos in order, you know we're on section 7 now, which is going over wireless. But our first sections we went over in our CCNA studies, we went over layer 2, layer 1, and we went over 802.3, which is the Ethernet standard. And the Ethernet standard, we should have went over carrier sense multiple access collision detection. So on Ethernet, this is where we listen for a signal, send if quiet, detect collision, and then resend. So imagine we build a road right here, and we have our collision detection guy wanting to cross it. Well, what he's going to do is listen to see if there's any cars coming. If he doesn't hear any, he's going to cross the road. But if all of a sudden a car goes beep, beep, and hits him, that's my best drawing of a car, he's going to back off and then resend. Contrast that with CSMA/CA, which is 802.11, which is wireless. This is how we send wireless packets via, layer 1, layer 2. So it's going to wait a random time, and then it's going to send. So he's going to, with CA guy, he's going to walk across the street, and then if he makes it, good to go, right? But how does he know? How did he actually make it across the road? Well, he's going to wait for access point guy to send an acknowledgement saying, okay, you can come across now. I don't see any cars coming. So that's the difference between collision avoidance and collision detection. Where with collision detection, essentially, it's okay if there's a collision. You're going to back off and resend later, hoping that interference or that other station stops transmitting in time for you to send. Well, with collision avoidance, you're not letting the collision happen. You're waiting your time to actually send, and you do that by getting acknowledgments back saying, okay, you can send. So how does this play into Wi-Fi? So really, these two technologies were built for half duplex communication. Meaning we couldn't have a switch here with 4 stations hooked up all sending at the same time, because back in the day we didn't have full duplex, so you could only send or receive, not send and receive. So you didn't want collisions on this switch happening all the time, so that's why we use CD, collision detection. Where essentially our stations would just have to wait until there's no more collisions. Obviously it's very inefficient, and on our traditional wired networks, we have full duplex. We don't got to worry about that. But with wireless, it's always going to be half duplex. Now, why is that? That is because you cannot get over the radio fundamentals, which is that if I'm sending a radio wave, you have to receive it, decode it, and then send it back. You cannot transmit and receive on the same time using the same frequency. Now, if we have like a receive frequency and a TX frequency that differs, and on the other end, right, you have the opposite, and this was just, let's say, one antenna talking to like one satellite, then that's a little different. You're sending and receiving at the same time. However, in our wireless networks, these access points may not have 254 radios that can send and receive at the same time, and we don't even have the frequencies available for that because we have our ranges. So we have to use something that avoids collisions when we have times 100 computers all connecting on the same 2.4 gigahertz range, and we're using only channel 1. Because we're only going to get 22 megahertz of actual bandwidth in our frequency to use for 100 people. So they're all going to be sending on that same channel. Not every individual computer is going to get their own channel. So that's why we operate and have duplex, and we have to wait. So now we kind of just take this full circle. If we go back and say, okay, so again, what does this have to do with Wi-Fi or wireless networks? This is getting into how this computer, this Wi-Fi enabled endpoint, actually begins talking to that access point. So what we're going to go over in the next few slides is the different frame types, the different 802.11 frame types, which is management, control, and data. So management frames are going to be how we associate with that access point. So this is where we're going to send probes. This is where the access points may send beacon frames, advertising the actual SSID. This is where we're going to get an authentication request. So in these management frames, this is doing our initial connection to the actual access point. And then the final thing is going to be an association message. So then once we're fully associated, now how do we start sending data? Well, now we're going to use control frames to do a process called RTS and CTS, which is a request to send. And then CTS stands for, sorry, I'm blanking right now, clear to send. Sorry about that. Just had a, sometimes it happens. Clear to send. And then we also have acknowledgments saying, okay, there's the final acknowledgement, start sending your data. And then we have the data frames, which is essentially just going to be our payload, right? Now this is how we are getting onto our network, getting resources. So CSMA/CA happens here at the control. So you see this RTS, the CTS, and acknowledgement. That's essentially the collision avoidance happening real time. That's the computer sending a request to send, the access point checking to see if any other channel is requesting, if there's any overlap, saying, nope, you're clear to send, this sending back an ACK, the access point sending back another ACK, and now we're sending data, our data payload. So there's kind of like 3 steps, and I was debating whether or not I am going to do like a Wireshark capture for you guys, but seeing as this is the CCNA exam, not a CCNP wireless training, we don't need to go that in depth. This overview right now, honestly, I would feel comfortable finishing this and maybe the next slide going over the actual frame format and then being done. But we're going to go a little bit deeper, kind of break this down in its own sections, and then we'll be finished going over this wireless fundamentals overview section. So with that being said, let me clear this off and let's go move on to the next slide. Okay, now let's jump into the 802.11 frame format. So again, we're just doing a high-level overview of this. So for some of you guys that may be more familiar with wireless already, and you're jumping into CCNA to learn routing and switching, you know that this frame format, like in the frame control here, it can change depending on what 802.11 standard you're running. Are you using, Wi-Fi 4, 5, 6? Is this N, AC, AX? We know that, right? We're doing a high-level overview, just kind of doing the basic frame format. And I'm pretty sure when I pulled this image off Google Images, this was a data frame. Again, we're just doing this to kind of get the high-level overview of everything. So with that being said, with this frame control, this is actually the section that's going to be telling the type. So what type of frame is this, right? Is this a control frame, management frame? So again, a field in the 802.11 frame contains control information about the frame, its type, subtype, or duration. And then the duration field, this is going to serve as the transmission and serves as the identifier for the frame. So again, how we use this duration or ID field is going to depend on what type and subtype of the frame that is being sent. So again, is this control, is this data, is this a management frame? And then we have the different addresses, which I am going to touch on a little bit. So first, let's just go over the basic definitions, right? So we have 4 addresses here. Contrast this with an 802.3 Ethernet frame or header that only has 2, which is the destination and source MAC addresses. Well, as we see here, we got 4 addresses here. And this is going to make a little sense if you actually look at the flow of traffic in a Wi-Fi enabled network. So if this computer is connected to a access point, and that access point is connected to our wired network, where the default gateway sits right here at this router. If we take a few steps back in our learning, we look at 802.3. When that computer needs to send out to the internet, his 802.3 header or his frame header, the destination address is going to be this router's interface right here, MAC address, and then the source is going to be his own MAC address. But when we put an access point in between, which is bridging the connection between wired devices via wireless, well, we need this computer, or whatever it is, right? Computer, laptop, cell phone, to be able to talk at layer 2 to this access point. So we have to add 2 additional addresses in there, because if we just sent a source and destination of this computer and this access point, and this is running like, let's say, lightweight, that does not have any routing capability, we would never make it to the router, because it would strip that frame. You see what I'm saying? So we need more addresses to tell us, hey, I have a source and destination address to make this 802.11 connection with you access point, because we're using wireless here. However, I need you to know my original address, and I need you to know the final destination address so that I can still communicate to that router over there on the wired network, and he can communicate back to me. So let's go over these. So we have the receiver address. So this is the MAC address of the receiving device. We have the transmitter address, the MAC address of the transmitting device. And then we have the source address and destination address. So this is the MAC address of the original source of the frame. So that's going to be your computer right here. And then we have the destination address, which is more than likely, depending on what your destination is, would be something like, let's say, the default gateway, if we were sending traffic out towards the internet, right? So let's just go over like a quick example here. So really the usage of these fields depends on the type and subtype of the frame. So in a data frame, the RA and TA, that's the receiver address and the transmitter address. And again, we're talking about a data frame here, a data frame type. So this is actually sending, the payload. This is the frame that's not doing any control and management. This is the frame that's sending that email message for us. So the RA and TA fields are going to specify the addresses involved in transmission. So that's going to be the access point. So the RA and TA, if we were to draw this access point out, as you guys have been watching my videos, I'm not the best artist. The RA, the receiving address, would be like this radio right here that's receiving. And then the transmitter address would be this right here, the connection to the switch. So because remember, this is essentially just a bridge to connect our wired network to our wireless network. That's the whole point of that access point, is to be able to get Wi-Fi enabled devices to talk. So we're going to need that receiving address and then the transmitter address. And then in the management frame, to kind of contrast that, the RA and T fields contain the MAC address of the access point in the actual client. Now, why is that? Because in management frames, this is how we do our association. So when we build a management frame, the RA and TA are going to be the access point and the client. And that's because that's how the client initially makes connections to this. And then the source and destination address may just contain, broadcast or multicast addresses, really just probably like all Fs. Because the point of that management frame is to associate to that access point. So you can see if you were to do a packet capture, all 4 of these addresses may change depending on what type of frame you're actually sending. And if you keep going on the videos, go over our message types, this might make a little bit more sense. So the sequence control. This is a field that allows the receiving station to identify and correctly order frames that were transmitted out of order or fragmented during transmission. So within this field, this source control field, which is, again, it says 2 octets here, which means 16 bits. You're going to have 2 subfields. You're going to have what's called the sequence number, and you're going to have what's called a fragment number. The sequence number is going to be 12 bits, and that's going to be used to number each frame sent by the station, starting from 0 and going up by 1 for each new frame. So this allows the receiving station to identify and reassemble frames that were fragmented during transmission. Then the fragment number is going to be 4 bits, and that is used to identify which fragment of a larger frame is being transmitted. So if a frame is not fragmented, the field is set to 0. So when you combine these, right, to get our sequence control frame, this field allows the receiving station to identify and correctly order frames that could have been transmitted out of order or fragmented during transmission. So essentially this just does a little bit of flow control, but it differs from the FCS field. This is going into actual fragmentation and sequencing as far as 802.11 is concerned. And then QoS control, if you want to learn about QoS, go back to our QoS videos, but essentially, just like in layer 2, Ethernet headers, 802.3, we have a field here for QoS, so to do our COS, right, our class of service. You can do that as well with Wi-Fi. And then we have the HT control field. So this field is an 802.11 frame that is used to support what's called the high throughput feature, which was introduced in 802.11n, which allows us to make use of the entire 2.4 gigahertz channels to actually give a station transmitting via Wi-Fi the full 22 megahertz to give it that updated speed of 54 megabytes per second. So HT control is only going to be on those 802.11 frames. So you may be asking, well, what about 802.11 AC? Well, that, my friends, is called very high throughput. So then it allows us to get those Wi-Fi 5 speeds. And again, we're not going to dive too deep into it. But essentially, if you ever want to learn or become that wireless engineer, you may need to learn about HT control and what actually gives us those updated speeds, right? Even though we're using the same channels and frequency ranges from before, like the differences between Wi-Fi 4, 5, and 6. Then the FCF field, the FCS field, is the same as it is in 802.3. It's used to check for errors on the frame. Okay, let me clear off that screen. And now let's get into the 802.11 association. So this is kind of getting into, okay, so you taught us about the frames. We kind of went over that overview of 802.11. Now, how do we actually associate to our access point? So the association process is going to be used to establish that initial connection between this client and this AP. So during this process, what's going to happen is the client's going to just essentially request to associate with the access point, meaning, hey, I saw your SSID, I'm a part of your basic service set, I want to join you. I want to send 802.11 messages to you. And then the access point is going to send back a response saying, okay, come join, or a rejection message. And then after this association is complete, then the client and access points begin their full communication of 802.11 frames. So now we're going to start sending control frames and then data frames to actually get our data. So to kind of break down even further what this 802.11 association looks like, so we have a process here. So here on the left we see our client, and then there on the right you see our access point. And I'm going to bring my pen application over here so I can quickly change between these colors. No, I haven't learned the hotkeys yet. I will though. That's coming in the future videos, guys. Don't worry. I'll learn the hotkeys. Okay. So if we're going just over a typical 802.11 association process, meaning brand new computer here that's doing what we call active scanning. So that means that this computer is sending out probes looking for SSIDs to see if it's part of any basic service set. Contrastly, we have something called passive scanning. And that's where the AP is sending out beacons, hoping to get clients to join. Right now, we're going to go over association as if we're doing active scanning, okay? So the first thing that's going to happen is the client is going to send a management frame, and that's going to be a probe request. So this station here, the client, is going to send a probe request to this access point. SSID, let's say, is AP1. And then this access point is going to receive that probe and it's going to say, okay, I just got a probe request from one of these clients. I'm going to send a probe response. Once the client receives that, now we're going to do our authentication steps. And yes, if we're doing encryption security, this may be encrypted. We're going to get to that on our wireless security section. But next is going to be an authentication request. And then can you guess what's next? That's going to go to the AP. The AP is going to receive that request, and guess what it's going to send back? An authentication response. So this is going to be, okay, yeah, come join this basic service set. We got room, playa. You're ready. Let's do it. And then, after that authentication is good, it's going to say, okay, well, yeah, let me associate with you guys. Let me become part of your basic service set. Let me rep your colors. So once the AP finally receives that association request, it's going to send back, you guess it, an association response. And then once that little song and dance is complete, now that client's a part of this BSS, that basic service set on this AP access point, and now we can start sending control and data frames. So if you want to take a second, write this down, please feel free. Pause the video and make that happen. And now moving on, let's go over the different connection states. So we just talked about the association process, right? So before we're associated, that state is called not association, meaning the wireless client has never been connected to any access points and is searching for a suitable access point to connect to. So this is where it's sending its probes. It's saying, hey, who's out there? Where's my BSS guys at? Associated, that's when we've already completed that entire association request, response, song, and dance. And now we're connected. See, these guys are connected. They're happy and smiling. The client and AP are connected. And then we have disassociated. So this is where, for one reason or another, the AP, or maybe an evil AP, maybe a hacker, has sent what's called a disassociation message. I just forgot how to spell all of a sudden. Disassociation message to the client saying, hey, get off my BSS. I don't want you connected no more. And then if this computer wants to reconnect, he has to go back to the not associated state before sending any probe request any association request. So those are the three different connection states. And then moving on, finally going over to our frames. So this kind of rolls in perfectly. You know, I just went over how a computer gets connected, and I wrote it out for you. But look at this, management frame. The management frame is that association request, essentially. The client asking that AP, hey, let me be part of your network. Let me be part of your basic service set. So what is the management frame used for? Used for network management tasks on an 802.11 or wireless network. It does control, access, authentication, association, and disassociation. So a disassociation message is a management frame. It also provides information such as any beaconing, so AP sending out messages, probes, requests, and responses. So again here, there we have it, the association steps, again, written out for you. And again, all these slides are available for download as well, so please feel free. If you don't take notes, you got it. And now let's get into the control frame. So I went over this in the beginning of the video. This is when we talked about carrier sense multiple access / collision avoidance. So control frames are how we do this collision avoidance dance, right? So let's go over this. So again, let's just go over the basic bullet points. So control frames are used for flow control and error checking. And this is not in the actual data payload, but in the actual 802.11 wireless connections between client and AP. They manage traffic. They do power management too. So something to note, they do power management for our access points, okay? Something to remember. And they do frame acknowledgement. And then of course they help improve network performance reliability because we avoid collisions on our wireless network. So here's how this works. So let's say we have PCB here, PCA. They're both part of this basic service set on AP, let's say 1. So they both did their association. They're both connected to that access point. Now they want to start sending data. So before both these PCs just start transmitting data like crazy, what they're going to do is transmit a RTS to the access point, which is encapsulated in the control frame. So this control frame is going to have what's called an RTS. The RTS stands for request to send. So the access point, if it gets both these requests to sends, it's not going to let both send because it's trying to avoid collisions. So it's saying, no. Only one of you can send, because if you both get the clear to send, we're going to have a collision on our channel 1. So what's going to happen is it's PCB, let's say, is going to back off, or it just doesn't send an RTS at the same time as PCA. PCA is going to resend that RTS, and then AP1 is going to say, cool, I'm giving you the clear to send. And this clear to send actually goes out to all the other wireless access points saying, hey, PCA got the clear to send. So don't be sending me no RTSs. You should know better. I just gave PCA the clear to send. So PCA is going to receive that clear to send. It's going to say, nice, let me send my data. So it sends its data, and then once that data transmission is complete, or the access point says, okay, hey, you've had your time, let's have others send data, it's going to send an acknowledgement back to PCA and the other PC saying, cool, his data got sent, now let me hear some more RTSs so others can send data. And that's all done in an 802.11 control frame. So that's going over the flow control. That's how we have collision avoidance, by this kind of flow with the RTS, CTS, and acknowledge messages. Then last but not least, a data frame. Save the best for last, or the easiest for last, because a data frame comes after the management and control, and it's just used to send data between client and access point. It carries the payload, and you need the data frames to actually, work on the network for our users. So our user traffic is going to be 802.11 data frames. Alright, so that's going to end it for this wireless section, going over the wireless fundamentals overview. In the next few sections, we're going to get into the standards and the regulations of Wi-Fi. And then we're going to go over actual wireless LAN deployment and demonstrations. So I'm going to power up my 2504 wireless access controller. I'm going to show you how to deploy a wireless LAN controller. Going to show you the switch configurations that you need. Going to show you how to deploy or plan for a wireless LAN deployment. Going to show you how to connect access points and then get into our lab, and then we'll be done. Whew! So take a deep breath. I know this was a long video, but wireless is just like that. You know, it's a whole career field in itself that CCNA says, hey, you need to know about this, and then gives you off-the-wall questions on CCNA. Thank you, Cisco. We appreciate it. We appreciate it as trainers because now we're going to deep dive into something. So, thank you for viewing, and stay tuned for our next video.